time. And the dogs.
Sorry, I had to start recording. I forgot. Go
The
for it.
dog is helping me. Log the
That's pretty cool. So how do you get those core samples?
So it's a special type of drill bit. It goes on and it's a special type of rig that can actually core continuously. And so there's a little bit that goes on the end of the drill string. And I always tell people it looks like a donut that's just studded with a bunch of diamonds. So it's got a hole in the middle, and it's got kind of a rounded edge around the ends, and it's got diamonds in it. And those diamonds, as the bit drills, it just kind of grinds up, those diamonds grind up the rock, and then the solid piece of core goes up through the middle. And once you get a certain length of it, I can't remember what it is now, maybe 20, 30 feet, then the guy sends a little wire line down the middle of the drill stem, and it snaps onto a little prong and then pulls the core out, and then we lay it out. And then they drop that core barrel back down in again and keep going.
Wow, that's awesome. So
Yeah.
how long can these samples be?
What is it now?
How long are the samples?
It varies. It all depends on the depth you're drilling to. I mean, we've done some that are, 50 feet, and we've done some that are 800 feet.
Nice.
Yeah.
Do you guys have any questions about core samples?
If you do get a core sample, what do you put them in?
So if you go back, you can see there's a little box there. Typically what we would do is we would take the coal that we were drilling for in this case, and we would sample it and send it off so that they can burn it and test it for chemicals. And we kind of knew how much sulfur and how hot it burned and all that kind of stuff. And if you see that little box down there, it's got a little piece of core sitting in it. We would do about 10 feet of rock above and 10 to 20 feet above and 10 to 20 feet below the coal. We would save that. And we would save that because in the mine, you have to know what the roof's going to do. Is it going to fall in or not? You got to know where your bolts, because you shoot bolts up into the roof to hold it up. We wanted to know what kind of rock. We wanted to preserve that record in case there was ever a problem in the mine where this hole was. The rest of it we would just chuck into the woods. Unfortunately, I hated that because it's rock and it's a rock sample, but that's just the practicality. You can't save all of it. So
Cool.
And this is in the mines, I see.
Yeah, so these are this is actually when I was in graduate school. And I'm beardless, so my kids who are on the call are probably shocked right now. But yeah, these are the ones where I'm kind of squatted down looking at the coal seam, and the one where I've got this thing coming out of the roof. Those are actually in Western Kentucky, underground. And I believe, if I remember correctly, the black stains on the roof were actually oil from the surrounding rock that was actually coming into the mine. But I'm just looking at the coal seam. This was a really special case. We wrote a paper on it that we published. That's what we were doing. We were collecting the samples for that. In the mine where it says Kentucky, that's actually the underground limestone mine. If you see the big pile of rubble behind me, that was a roof fall where the roof actually came in. Yeah, and you can actually see, if you look kind of just a little bit above my head and above my right shoulder, you can see a linear kind of piece sticking up out. That's a bolt that got ripped out. So dangerous work for sure.
So that's a limestone mine.
Yeah, and the difference being, most of the coal mines I worked in were about 3 feet tall. The one we were digging in there, that you can see, obviously I was standing up. That was probably 6 feet or so. The limestone mine was about 25 feet high. You could actually drive pickups and big dump trucks and stuff underground. So that was pretty neat.
Awesome. Kids, any questions?
What was the temperature in these caves?
They were, it was pretty steady, right? And except for when you got out toward where the surface was. But once you got back in the mine, it was probably 60s, low 70s all year round. So,
Mike,
nice.
how far below the ground surface were you?
Ooh.
I've been as deep as 600 or 700 feet. Those mines I worked in were probably 200 to 300. The ones I actually worked for. I mean, the ones I'm digging around in, those were much deeper. And
Well,
the
that's a-
neat thing about those, when we drove into those mines, you drove in and you would cross a fault and you would go into a completely different coal seam. And then you would drive for a little while and then you'd cross another fault and you'd go back into the coal seam you were in originally. So that was a really neat mine. There's just some neat stuff you get to see when you go do that kind of stuff.
Well, you can't be claustrophobic, that's for certain.
No, 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 you can't be afraid of the
No.
dark either. It gets pretty dark under there. So.
Well, that's a really good segue to this, guys. All right, who can tell me the layers of the Earth? Just
Crust,
the basic-
mantle, core.
What? Actually, it's crust. It's crust, mantle, outer core, and inner core.
Well,
Okay,
okay.
yeah. So there's an outer core and inner core. That's right. Because which one is kind of the molten one?
The inner.
The outer core.
I think.
Wait, no, the inner core.
I think it's the outer core, right?
I think
Mr.
it's
Mike?
the outer core actually too.
The outer, yeah.
Okay, and do you guys remember, now for those of you that were in our last class, how do we know that there's a molten outer core?
Because of the iron in the center of the earth. Because of the
Okay.
magnetic field, I mean.
Good. It's a good
Magnetic
guess.
fields.
That was a good
Okay,
guess.
that is, yeah,
Speaking
there
of,
is. No?
Speaking of materials, and I think it's 2067, the world will run out of materials, natural materials, and we'll have to use asteroids as a source of thing. I don't know. I don't know if that's true or not.
If you understood the error associated with those guesses, you probably wouldn't repeat them.
Yeah. I don't know if they're real or not.
Back to Miss
So,
Tara's question, how do we know the core is molten?
the hint is on this slide.
Okay, Desiree.
Okay, is the mic working?
Seismic waves.
Okay. The iron's moving in the core, so we can tell the gravitational fields happening because of that. So that's I
Okay,
think that's part of the reason that we know it's iron in the core.
yeah, the magnetic field, yeah, for sure. And then we use machines that measure seismic waves. Do you guys remember we use something called an S wave and a P wave? And which one can't go through liquid phase?
The S wave?
Mm-hmm. Yeah. So we can actually see which part is solid and which one is liquid, right? By the different waves that come out the other end. Am I saying that right, Mr. Mike?
You are.
Okay. Correct me if I'm saying anything wrong.
Yeah, no, the S waves won't travel through liquid, that's for sure.
Okay, so do you guys see how thin the crust is compared to the mantle, right?
Yeah.
All right, so we'll be, yeah, thank you. All right, so my question to you is, why does Earth have an iron core?
Maybe from all of the molten lava and all. Maybe the rush.
it's heavier?
Yeah, very good.
Pressure.
It's heavier. Yeah, so why doesn't it have like a silicon core, right? Because what is
it's
the
lighter?
mass? What is the atomic number of iron there? How many
26.
protons does it have? Yeah, it has
20.
so it's pretty heavy, right? So do you remember when, just like in the core of a star, how the elements are formed? What always sunk to the bottom of the star in the core? Iron, right? That's right. And the heavier elements, where do we get all of our heavy elements on Earth? Where are those formed from?
Deep within the ground.
No. They are deep in the ground, but where are they from?
Labs.
Who remembers in our star unit what happens when after a star dies?
Explodes.
Supernova.
There you go. Our heavy elements are from supernova. Okay, so that's where we're getting all of the minerals we're going to be talking about today. All right, here is the $1 million question. Can you dig a hole through the earth to get to the other side?
No,
Not yet.
Nope.
Not yet.
not yet.
It can, we can try.
Can you in theory?
Yes.
Yes.
What would
Oh,
you,
we don't
what
have the
would need-
materials to do that.
No,
All
in
right.
theory though.
why though? What's so wrong about going through the earth?
Because
There
it's
is a
so hot.
literal molten lava center and so much pressure that it would crush you.
And it's
What if we like encapsulated it, a hole in something,
Gravity
and you
tunnel.
drove like with a ship?
Gravity train.
Yeah, a gravity train. What if that happened? Could you go through the earth?
One of those bullet trains they use in Tokyo.
That would just melt in the molten lava.
Yeah. We don't have anything to deal with the heat yet.
Yeah, how
And
hot
you
is
would, wouldn't just be
God,
you wouldn't just be going down because you also have to be going up after you reach the middle.
Temperature.
I was like 1,000.
Yeah, it's a good point. Gravity flips halfway through, right?
Mm-hmm.
It reverses.
So how deep have we dug? What is the biggest hole we've dug so far on Earth?
It was like
40
10,000 miles.
The Kola borehole in Russia, it is 9 inches wide and you can't fall through it. It, I think, goes over 7.6 miles deep.
It says 40,502 feet.
All right, Mr. Other Mike.
Yeah, it's
You want to answer the question?
yeah, it's kind of funny, and these records that are on the page have actually been broken as of recently. There's
I don't know if you guys said this yet, or I don't know. I was using the restroom. So the deepest hole that we dug is the Super Russia borehole.
how deep was that?
It
A super deep borehole.
So here's where the interesting part of geology and tectonics and how the earth is formed comes into play. When you talk about the deepest hole we've ever dug or drilled, really, you have to talk about it in terms of vertical depth. Imagine drilling straight below your feet toward the center of the earth, and measured depth, meaning how long is the hole. You can see on the page here where there's an example on the far left of kind of a vertical borehole, but that's not actually how far vertically we drilled into the earth. That bore actually comes down vertical for a little ways and then turns and goes horizontal like the picture on the right-hand side of the page. And we drill directionally like this into different reservoirs to increase the amount of contact we get with that reservoir. It's like putting a straw in a balloon that's buried underground. If you want to get more out of that balloon, you put your straw as far into it as possible, and then you poke holes along your straw so all the air or the fluid in the balloon can come through those holes at a faster rate and back up the straw to surface. So the record was just over 40,000 feet. But that was just broken by our team, our drilling team in the UAE. Anybody familiar with what part of the world the UAE is in? It's kind of Middle East.
Sounds like
United Arab
Ukraine
Emirates?
something.
That's right. That's right, the UAE, United Arab Emirates, and we just drilled one that is over 45,000 feet long. That's over 7 miles. It's pushing 8 miles into the earth.
This is a good example here. When you fly in an airplane around 40,000 feet, maybe not quite that high, but so it's, if you took the distance up high and flipped it into the earth, that's how far away you are. And here's a really good picture of submarine depth, right? And Mount Everest is around 29,000 feet tall. So if you flipped Mount Everest upside down, we still dug farther than the top of Mount Everest.
Wow.
Yes, Lil, oh, I thought you had a question. Any questions?
Can you imagine the amount of technology and work and engineering and geoscience that goes into designing and executing a project like that?
Yeah, how long did it take to do that?
Years.
Wow.
They use like robots to go down there. Like there's no humans down there, right?
Big
No,
drills.
humans can't survive that deep. I'd be happy to do a separate lesson on drilling rigs and drilling technology at another date, but so funny enough, I work for ExxonMobil, the company that drilled that longest well. In fact, we have 5 to 6 of the top 10 longest wells in the world. So we have
You're
engineers and well, no, I'm not. The company is. we have people like myself and Mr. Mike Shultz who work every day on teams developing techniques for drilling farther and better wells. But it takes years of planning to get to the point where you can actually do it. The picture you can see on the left is from what we call
Is
the
that
rig.
you on the rig?
It's me on the rig. This is us actually running some of the technology into the well from a rig on surface. Now, this well wasn't near as long as the other ones that we just talked about, but it's a good example of what it actually looks like, where you put the tools into the hole so
Oh,
you
is that a
can drill
puppy?
farther.
Yeah, look at the top. Look at the right. There's a puppy.
There's no puppy on that rig. Couple of
Sorry,
dogs,
I
but no
was
puppy.
Sorry.
That's fine.
How
Okay,
deep is the
so-
deepest hole?
Ma'am?
How deep is the deepest hole in United Arab Emirates?
I'd have to get the exact number, but it's about 45,000 feet.
So what are your limitations? Hey guys, what do you think? Why can't they drill any farther?
Pressure and heat.
Yeah, pressure and heat. I was gonna say that.
So what do you think happens to like the drill bit at the end?
They burn.
It melts.
Incinerate.
It melts.
It melts. And funny enough, there's a mod on
Crush
Minecraft
and
that's
melt.
literally about they drilled a hole into the core of the earth. It was interesting.
Does it melt, Mr. Mike?
I'm sorry, say that again.
Will the drill bit melt if it goes too far into the earth?
I would think so. It's pretty hot down there, right?
According to my theory, yes, it will.
They would actually melt at some point, but the limits we reach are well before that. The material gets softer as it heats up. So it doesn't
harder to
actually turn
drill.
to liquid, but it's not as tough as it needs to be to drill through solid rock. So there are limitations on both temperature from the materials standpoint and pressure.
Yeah, because if it's soft, right, it just seals back up. it
So
gets
what
to a
are the
certain-
materials you need to drill down that far?
It's proprietary.
Is it
Very,
diamond?
very expensive. We do use industrial grade diamond bits. Yes,
Mhm.
like Mr. Mike talked about in the coring example he gave, we use different looking but very similarly functioning bits that have industrial grade diamond tip cutters in some cases. Because diamond is one of the hardest naturally occurring materials on Earth. It's readily available for commercial use. So
What if you ran into a diamond in the ground while using the diamond tip? Or is that even possible?
I suppose it's possible. I've never done it. Mike, have you?
I never have. But you could theoretically hit a diamond pipe, which they're kimberlite pipes all over the place. There's some in Arkansas that we've been to, and they have little diamonds in them, but they're so dispersed. It's not it would be, that'd be pretty
Extremely
fantastic.
rare.
Yeah.
All right. What do we find, guys, when we go drill deep into the earth? What do we find?
Water, ocean, dirt,
We find
crystals, rocks, gems.
it was naming like everything.
Iron,
Nobody else can think of anything.
Anybody else?
iron, I would think.
Rocks,
All right, I heard an iron. Yeah.
like maybe
We
like lava
find-
or magma.
Okay. So if we just stay on the crust area, what would we find if we dig?
Definitely dirt.
Rocks.
Do you know what type of rocks?
Sandstone.
Sedimentary
Uh,
rocks.
Maybe
Sandstone, perhaps.
maybe volcanoes. Not like the volcanoes, but like underwater volcanoes.
Volcanic rock. Is that what you
Sandstone.
mean?
Or metamorphic rock, or igneous rock, or sedimentary rock.
Which leads us to rock formation, guys. So I actually love this slide only because it's just crazy looking. Can anybody from this slide kind of go through, who knows the rock cycle already? So we're going to start off with
Oh.
right? We're going to start off with our magma, our molten rock. And then what happens? Where do we go from there?
It erupts.
Well, some of it stays underground, right? What is that called? Here, I'm going to do blue. What is that stays underground? The magma.
Igneous rocks.
Sure. I highlight it here. It's called intrusive igneous rocks.
Oh.
And what's an example of that?
Granite.
All right, so we got our intrusive magma, and then what happens, guys? What if it comes out of a volcano? What is it called then?
Becomes an extrusive igneous rock.
Thank you. Good job. All right, Mr. Mike, did we get that correct with our igneous rocks?
Yep. And then there's different kind of cool names when they get emplaced into the ground. They're called plutons, which is, you got plutonism there. And there's different types called like batholiths and laccoliths and things like that we study. But they're just granite, or typically a siliceous magma that's been emplaced in the ground. And we make countertops out of them when they finally get to the surface and we cut them up.
That's why it's so expensive.
That's why it's so expensive. Yeah.
You got a volcano in your house.
Sure, yeah, from a volcano, right? All right, so after we, oh, was there a question? Okay, after
I'll tell you,
the
I'll tell you
rock,
one little neat thing, that thing that says pegmatite right there. Those are really interesting because they're basically a lot of water in this type of system, and the water becomes supercritical and it pools up, and you get these things called pegmatites, that you get these big giant crystals that grow in them. And a lot of times people try to find those and mine them because there's a lot of value in that. But that's what those pegmatites are. They're a real special kind of deposit.
any questions, guys? You guys see that?
I don't see the pegmatite. Where is it?
It's right by the igneous rock label there. It says
Oh.
pegmatite.
Oh,
Right there.
All right, so once we get extrusive igneous rocks, we form maybe some basalt. If it's near the ocean, or yeah, did I say that right?
The magma hardens.
Tends
That's
to be more
right.
iron rich. Yeah, not the oceanic stuff's more iron rich, and has a lot less water associated with it.
All right, so then we're going to follow our little diagram here. And what's the next type of rock we're going to get? So we have mechanical and chemical weathering will happen to this igneous rock. And you'll get little sediments like gravel and sand and mud and clay, all right? And they'll start layering. And what are those rocks called?
Sedimentary rocks.
That's right.
I have a question.
Go for it.
Is this a mafic or felsic volcano?
Good question. So the volcanoes like you see in Hawaii, those are going to be mafic, and you know that typically because the lava tends to be really runny. Like the basalts are really runny. They're not thick and sticky, and so that's why they build shield volcanoes, because the lava comes up and then it just flattens out and runs off, right? Volcanoes like Mount St. Helens and Mount Rainier, those are steeper, more rocky. Those are typically felsic lavas that build those up, because the felsic lava tends to be thicker and stickier, and it's also much more explosive than the mafic ones.
Okay.
Now that we have our sedimentary rocks, here's where both of the Mr. Mikes were talking about drilling into the ground, right? And finding oil and gas, and you could find some fossils maybe, and coal, right? And then a lot of pressure and heat happens, right? And what type of rock forms then?
Diamonds.
Metamorphic.
Metamorphic. And those can go to the surface, or they, I guess, can get remelted and the whole cycle starts again. So that's what we're going to be talking about today. All right, so that's the rock cycle in a nutshell, in a rock shell. So we've got igneous, sedimentary, and metamorphic. And it kind of cycles around. Does everyone see that? Any questions about the rock cycle?
No.
Okay. So I actually want to go to, we're going to talk about igneous rocks first.
Miss Tara,
Yes.
what's the most rarest rock that is naturally occurring?
Here you go, Mr. Mike.
The weirdest rock.
The rarest. I think he said
Oh, the rarest. I'm sorry, the rarest. There are types of lava
I'll take that one from me.
that have a lot of carbonate associated with them. I think they're called carbonatites, and those are pretty rare, and they contain material in them called rare earth elements, and those are really valuable for making batteries and magnets and things like that we need for our technology. So those are probably the more rare type of rocks. You know, if you're talking about diamonds and things like that, those are pretty rare as well. But I mean, an actual rock type, I would call that carbonatite a pretty rare one.
All right, so let's talk about igneous rocks. So we learned that they form from both the magma under the earth and outside, right? So there's different types of rocks. One's from lava, right? Which is the magma when it comes out of the volcano. We have lava. So we have basalt, obsidian, granite, pumice, and I think somebody brought some obsidian, right?
Oh, I spoke gorilla.
So, question. So I heard of this. It was in my school. It was floating around, kind of. It was a rumor. I want to know if this is true. So apparently, in my old school, there was apparently a rock that it kind of like dissolves every 8 hours. Kids were telling, well, like they were talking about it. It's really rare because it kind of, you know, dissolves every 8 hours. So they couldn't really obtain it.
Are you mustard?
I'm not sure what that is.
Huh.
Yeah, I don't know.
Like a mineral has a half-life of 8 hours?
I mean,
Or-
yeah. Yeah.
Okay. Okay, so like a radioactive element type thing.
Think of peanut butter.
With this one.
Yeah.
Why is basalt peanut? What?
That was me.
Do you want this?
All right.
Okay, so this is the obsidian.
I want this one.
I don't know what
All right,
type it is.
Mr. Mike, can you tell if that's obsidian?
Well, the screen's kind of small. It looks, man, I don't know. It's tough to see. How do I maximize that?
It's definitely shiny.
Yeah, okay, let's see. It doesn't quite look like obsidian to me. It's really pretty. I don't know what it is. Can you back it
Yeah.
off from the camera just a little bit? Yeah, without kind of holding it and looking at it, I can't quite tell. It doesn't look like obsidian though.
I was just told that it was obsidian whenever I got it.
It's pretty. I don't know what it is. It's something, but I can't tell quite what it is. It looks more crystalline. Obsidian is glass, right? It's volcanic glass. It cools very quickly and it just looks like glass. That has more of a crystal structure to it.
Yeah.
It looks like there's maybe even some, almost looks like pyrite, like fool's gold type stuff in it as well. But that may just be the camera.
So
Is this obsidian?
Still got the receipt.
yeah, that does look like obsidian.
Oh gosh, how do I get back to that?
Why do you have a spear in your room?
An arrowhead.
Why do you have an arrowhead in your room?
I have a lot of
pretty
stuff
cool.
in my room.
That's true, Ashwin. You collect rocks.
And filters.
And knives.
A lot of Native American, yeah, they use the obsidian for arrowheads. Chert as well, which is a sedimentary rock.
All right, so speaking of obsidian, what type of rock is obsidian, guys?
I think it's
Molten.
igneous.
That's right, igneous rock, right? Which, you know, the word ignis, or like in the word ignite, means fire. So these are rocks, fire rocks. Because they're from the hot magma around, it could get up to anywhere between, well, really hot, 1400 degrees C, which happens to be, I thought this was really cool, around the same temperature when the space shuttle re-enters the atmosphere and you see all that fire everywhere. That's around 1400 degrees C. So it's very hot, the magma, but it cools and it crystallizes. Does anyone know what crystallize means?
Make into a crystal or to harden into a crystal?
Right, so the molecules are just forming these repeatable pattern shapes, right? So if it stays underground, it's the intrusive, and if it surfaces, it's the extrusive. Now, Emma mentioned mafic and felsic rocks. So the way to remember mafic is the Ma from mafic is with magnesium, and the thick part is from the iron Fe, right? So it's mafic. It has a lot of magnesium and iron in it. And the example of that is going to be basalt. And then your felsic rock is going to contain a lot of silicon and feldspars. Okay, an example of that is going to be granite. So let's look at some examples. So Mr. Mike touched on this about mafic volcanoes in Hawaii. So why again, why do they don't explode with all the smoke and stuff, right?
Because they're more
They're
liquid
mafic.
than lava.
Say that again.
They're more of a liquid form than a molten lava, magnesium. Whatever.
That's right.
it is.
That's right. They have magnesium and iron. They have a lot more magnesium iron versus, so they don't have a lot of oxygen and the silicates in there, right? Is that correct, Mr. Mike?
Yes. So they have a lower viscosity. Yeah.
Okay, so they're not as thick, right? They're more runny, I guess. And then the felsic volcanoes, like Mount St. Helens. So why do they look like this with all the smoke everywhere, guys?
Felsic. It's a felsic volcano.
Which means what?
It's more explosive.
3 pennies.
They're high in
Viscous. I don't know.
Explosives, oxygen and silicates.
right. Thank you. So that's pretty cool. You didn't know there were different types of volcanoes, huh? And all right, so here's our thank you.
Wow.
So here's your obsidian, Ashwin, that you were holding.
What?
So obsidian is formed, and Mr. Mike, tell me if I'm wrong, is when that felsic lava, right, that has all the silicon dioxide and stuff flows into water. It's cooled, right? But it doesn't have enough time to crystallize. So it kind of makes a smooth, glassy surface. Is that correct?
Yeah. Fast cooling. Yep.
And how do you just find these on the surface generally, or is it generally underwater?
Oh boy, that's a good question. I don't know the answer to that. Yeah. Yeah. And if they're associated, I don't know if they're exclusively felsic. That I don't know the answer to. I mean, the picture there almost looks like pillow lava. I don't know that, but it kind of looks pillowy. And in which case it would be associated with being underwater, right? The pillow lavas are underwater, and that would allow it to cool faster. So I don't know that. Again, I don't know that it's purely. It may be more associated with mafic, but that's a whole branch that I haven't studied for a long time, so I just don't remember. My mineralogy professor is probably just churning right now. But it is quick cooling, and that's the moral of the story there. Yeah.
And if you guys remember, this is how the felsic or the felspar, right? It melts. And this is how we actually get argon in our air. So what is our atmosphere comprised of? What is it mainly, our atmosphere?
Oxygen and carbon dioxide.
Nitrogen.
Nitrogen.
Nitrogen. I was muted.
It's 71% nitrogen, right?
I said nitrogen before you all.
But it is 1% what?
Argon.
Other.
Yeah, argon. So this is actually where we're getting our argon in our atmosphere, is when this rock comes up, right? And it has, we learned about potassium going into argon, like through electron capture. We won't go through that, but it turns into a different element. And that argon is then a gas. And when it melts, the gas can be released. And when this rock solidifies, that argon is then trapped into the rock until it remelts again. So this is how we actually get argon in our atmosphere. All right, so why does a compass needle point north?
It doesn't actually point true north, it points magnetic north.
Ah, smarty pants.
Got a future directional driller on our hands.
So can a rock be a magnet?
Depends on how strong its magnetic force is.
Okay. Any other takers?
What makes it magnetic?
I think, I don't know if this is correct, but I think it like reverse. No, that's a different thing.
What makes it?
Yeah, what does make it magnetic? I think you're muted, babe.
The iron
Electrons?
in the core.
All right, so Mr. Mike, you want to explain how that happens? How we can actually.
This is a pretty cool phenomenon that I don't think a lot of people know about, but if you've heard of the mid-oceanic ridges out in the center of the oceans, right, it's where the earth is kind of pulling apart and pushing apart, and there's hot, magma that's coming up to the surface and breaching the surface and creating new ocean floor. And that's kind of what you're seeing there. The stripes are actually, because this is a iron rich rock, right, like a basalt, there's a lot of iron in that molten material. And because the material is molten, the crystals that are forming can still orient themselves parallel to the magnetic field. And then once that rock freezes or solidifies, those things get locked into place. And because the Earth's magnetic field does flip from time to time, the ocean floor actually preserves a record of that over time. And so those are the stripes you're seeing there. If you could, and they'll drive a boat, over the surface, and they'll have a magnetometer on it, and they can actually measure, the orientations and the magnetism of that rock, and they can map these stripes out across the ocean floor.
Does everybody understand that?
Isn't that called seafloor spreading?
Yep, that's seafloor spreading. That's exactly right.
Yeah,
part of the plate tectonic thing. Yeah. Yeah, and then there are other parts. I think I don't know if can't remember if we talk about it or not, but it does pull apart. But because it's not getting bigger and bigger, there's another part where it's going. That oceanic crust, the old stuff, is now being subducted, being pulled beneath the continental crust. But I don't want to steal anybody's thunder here for covering that stuff.
The other cool part that I learned about, looking through this is that if you look at the bottom of the right-hand picture, you can see where north and south on the compass directions aren't always pointing the same direction, which by the methods Mr. Mike just described, the Earth's magnetic poles through this method we think have flipped throughout the history of the Earth multiple times.
Yeah. So your north is not north anymore, it's south.
That's right.
And how many times has it done that? Do we know?
A bunch. A bunch, but I don't know the number, and I don't think they truly understand why exactly it happens. But I know they actively work on that, try to solve that. But there's been a bunch.
But this is over millions of years. Like, it doesn't happen every thousand.
No. It's maybe hundreds of thousands at the quickest, I would think. But.
Any questions, guys, about the Earth's magnetic field flipping?
Which hundreds of thousands still sounds like a lot of years, but when you're a geologist, you tend to work in millions, tens and hundreds of millions of years. So it all kind of becomes relative.
Is anything affected, like anything on the Earth affected while the magnetic field changes?
Well, it's not really changed in our technology time, but certainly to our technology there would be a pretty big disruption, and I couldn't even fathom all the different things that would affect. Historically, I don't know. I mean, birds obviously, migrate north and south. I guess it would affect them
Migrating
somehow.
north.
But yeah, again, this hasn't really happened in our existence, I should say, or and to a point where we would have any kind of history of what it would have done. Yeah, so I'd say it's pretty unknown exactly what would happen.
Go for it, Desiree.
All right, so to answer the question that was put in chat, it depends on where you are for magnetic and true north. You have to alter the direction up. So if you have a map, you have to orient it with the compass first. And depending on where you live, depends on how the difference between magnetic and true north.
That's right. What is the measure of that difference called?
I don't remember what it's called.
Homework.
Studying. Google.
You're
I'm not
absolutely
allowed to
right.
use
It
Google.
does depend on where you are, and it changes with time. That's another fun fact. Does true north move?
True north, technically, I don't think true north is supposed to move. I believe that magnetic north moves. I don't remember.
That's right.
Magnetic north moves, I think.
That's right. That's right. So the answer I'm looking for is that there is what we call the measurement difference between true and magnetic north. And the fact is that it varies depending on where you are, as well as what time.
Time zones.
No, like years.
Oh. Oh.
Even if you stood in the same spot a year from now, it could be different. So there's a bit of homework for you.
We don't like homework. You could just tell us the answer.
It's just regular work.
That's right. It's regular work. It's
Just
all
work.
Oh. All right. I don't know if this animation will work or not, but we will try it. All right, notice the time frame here. We have 200 million years ago, right? So this is, another 20 million years, and the north and south keep flipping as the seafloor is spreading. And each of these layers of basalt is locking in what direction north was.
South. Or like northeast from it.
It was
Go on.
you have the answer for the previous question now.
Ah. Yep. So this is good evidence of seafloor spreading, right? And that will eventually get into plate tectonics, correct, Mike?
Yep.
So do we know at what rate it is spreading?
I think they do. I think they have a pretty good idea. I don't know what it is, but they think they have a pretty good estimate.
The continents are what, like a couple centimeters a year or something like that?
That sounds reasonable.
Yeah. You won't notice it.
There are geologists that it's an interesting thing, right? There are lots of different types of geologists. There are geologists that purely study this kind of thing. There's geologists that study water. There's geologists that do what I do, which is more sedimentary stuff. This is stretching back 20 years to college on some of this. You're trying to quiz
Yeah.
me on.
Google it.
Yeah, there you go. Yeah, GPT, Google, whatever.
So a couple terms, especially for our Kahoot quiz here in a little bit, is basalts and then granite. So basalt is generally, and Mr. Mike, please tell me if I'm wrong, is generally formed more of the oceanic crust, and then granite is more the continental crust.
Yeah, that's fair. Yep.
Okay.
Yeah, basalt is more commonly like found or formed in like the ocean floor, and granite is more of the above the ocean.
No, it's more commonly found in the nether.
All right, so here are basalt columns. So basalt is the most common igneous rock on Earth's surface. All right, so how do these columns form, guys?
Water.
Mr.
Water.
I mean, I guess
Erosion.
Water.
Erosion.
Water.
Erosion.
Water.
Water, wind, fire, air.
There are different
all
types
together
of
they
erosion.
lived peacefully, but until the Fire Nation attacked.
All right,
Emma,
Mr.
what-
Mike, how did the basalt columns form?
Water.
As
Water,
as it
erosion.
cools, the basalt cools, I believe it's the crystal structure of the magma. It tends to break it out into those
Cool
shapes.
columns.
Yeah, and yeah. So, and you see like the oh gosh, the thing up in Wyoming, Devil's Tower, right? People talk about Devil's Tower. If you've ever seen that, it's columnar basalt. It was probably a volcano years and years ago.
All right, so fun fact, who knows what the Rosetta Stone is?
That's
Isn't
the
it that language app?
It's like the one that has like all the languages. You know, we actually saw the Rosetta Stone once in Houston.
I was about to say they do have a replica in Houston,
Yeah.
in the Egyptian.
Where's the original?
In London, I believe, somewhere in Britain.
Did somebody just call it a language app?
Yeah, because it is a language app.
The old Duolingo.
So it's made out
Oh,
of
wow.
black basalt, all right? And it was supposed to be how we're actually one of the first ways we could translate hieroglyphics for the Egyptians. So you'll find this generally in museums, more in the Egyptian area found in Africa. But that is black basalt. Whoop. Fun
It is
fact.
a language app too.
It is a language
Yeah.
app.
See?
All right, so who knows what this is?
The
Mount Rushmore.
Mount
Mount
Rushmore.
Not Rushmore. I was muted.
Right, so this is
Rushmore.
also made out of igneous rock. What type of igneous rock?
Granite.
George Washington.
Granite.
Why is it made out of granite? Like, why would you want to?
Because it was just carved into. It was just carved into a mountain.
It was what they had to work with.
Granite's good for what? Like, is it gonna erode away very easily?
No.
It's gonna stay there for a
It's
while,
very
and it did.
durable.
Anything else about Mount Rushmore, Mr. Mike? Do you know much about that?
No, I don't. I've been there, but I don't know much more about it now.
I want to go to Mount Rushmore.
It's
Yeah,
just in the
it's
middle of nowhere.
Isn't it in?
Oh, we know sedimentary
Like
rocks.
Montana.
All right, so we're gonna
Yeah.
go for about 5 minutes over time. Do we want to keep going a little bit? I'll go pretty quickly, or do we want to start
Yeah.
at the?
Kahoot.
Kahoot.
Okay, so we'll stop at sedimentary rocks, unless we want to keep going.
Kahoot. No, Kahoot.
I am that
No.
one person who
Let's
wants
keep
to
on
keep
going.
going.
Oh, we have a keep on going.
Keep on going.
Well, definitely do it. Mr. Mike,
A hoot.
Keep on going.
are you
Kahoot.
guys,
Woohoo.
hold on, guys. Are you able to be with us anymore? I know we've reached an
Yeah,
hour
I
mark.
can do a little bit more. I can do a little bit
Okay,
more.
so I'm gonna go over these pretty quickly just to kind of touch on the three types of rocks, and then we'll do Kahoot, guys. Okay, sounds good.
Okay.
Okay, so here's our sedimentary set. I keep saying that wrong. Sedimentary. That's right. So this is weathering, breaking the igneous rocks, right, into smaller sediments. All right. So, Mr. Mike, what do we use sedimentary rocks for?
A lot of things. I mean, there's just a lot of things in your daily life that you don't even realize comes from mining. The big one's really limestone, used for cement blocks, and the stucco, if you have stucco house, clay for bricks. Those are the big ones. A lot of different aggregates are in the roadways that we drive on. And then obviously oil and gas and coal, like I work on. And then the drinking water we get from the ground is stored in aquifers, which are in sedimentary rocks typically. I mean, they can be in a lot of other things, but a lot of what we have is in sedimentary rocks.
Kind of makes sense, like sedimentary, cement.
Yeah,
Cemetery.
limestone's a big one for cement. We mine it, grind it up, cook it at high temperatures to convert it to lime, and then that's what they make cement out of.
So there's two types. There's plastic. Now, am I pronouncing that correctly?
Yep, plastic.
Plastic sounds like plastic.
Right. And they're form clasts, which are these little clay, silt, sand, pebbles, cobbles, boulders, stuff like that. Those are little clasts, right? And they stick together. And the key ingredient with clastic rocks is, so if you can imagine sand, right? What happens when you build a sand castle and all the water evaporates?
That's not a sand castle. That's a sand house.
No, that's an awesome sand castle.
I can't,
But if
like, I feel bad whenever it gets washed over by the waves.
No,
That's
that
okay.
is simply from,
Or someone, like,
Dog
runs
the
into it.
Sand Dog.
So what happens when all the water evaporates from when you were building your castle? Would it just blow away?
Yeah.
Mm.
Yeah.
All right, so we need some sort of cement, right? Some glue for all the sediment to make a rock, right? So generally, the cement is going to be all those minerals that we were talking about, right? So a lot of calcium carbonate and silicon dioxide and stuff are used to kind of glue all of these pebbles and clay and sand and silt together to make these rocks. Now, what happens if all those minerals are there, but then we get rid of the clasts? What happens? So we just have the glue. What do we get?
A travertine is formed.
So, Mr. Mike, can you explain some of this about hot springs and what's happening?
Yeah, so this is hot water that's in the earth, and it's picked up limestone, basically carbonate material, and it bubbles up to the surface and forms these hot pools. And then the hot pools, eventually evaporate and leave behind the minerals in the form of travertine. And we can get things like, salt. That happens as well when you get a big ocean basin. Sometimes it'll be restricted for some reason, and all the water evaporates out, and you start to get these heavy brines, and the salts start to crystallize out. In places like Michigan, we'll see not Lake Michigan, in places like Michigan, you'll see salts that are 300 feet thick that resulted from things like this.
So this is where we're getting our salt.
Yep.
Like salt deposits.
Yep, salt like you eat on your, French fries. And then also there's a special kind of salt called sylvite, which has a lot of potassium in it. It's radioactive, but we mine that out. We solution mine it out, meaning we pump water down a drill hole and dissolve it and pump it back out. And sorry, I'm cutting through your slides, but
No, perfect.
we pump that sylvite out, and because it has potassium, we use it to make fertilizer. Salt's very important.
So this is a picture of one of the old salt mines.
Yep.
They get pretty large.
And you see how wavy everything is?
Yeah.
So those were once horizontal beds, right? And what happens with salt is salt, believe it or not, even though at the surface you can crunch it, right? It's crunchy. At depth, it gets warm and there's pressure. And if we put enough stuff on top of it, it will flow like toothpaste. And that's what you're seeing there. Is you can see the banding in it is actually that's how it flowed at one time. All those were horizontal. And so along the Gulf Coast, if Mike was still on, he could tell you there are things called salt diapirs, and they look like big salt lollipops that are under the ground. And usually at the top of them or around the edges of them, you get oil and gas accumulations. Pretty neat
So like
stuff.
it was a sort of like a Newtonian fluid, like you put pressure on it and it gets harder, but when you let it go, it just gets liquidy.
Yeah, it doesn't quite flow like a liquid, but like silly putty, like a non-Newtonian type fluid. And then if you did it too quick, it could snap, right? I mean, but it actually flows.
That's pretty cool.
Yeah.
And this I liked a picture of, because you had mentioned this in one of the first slides, the seams of coal, right? So here's our chemical sedimentary rock, or biochemical, I should say. And this is what you got your degree in. Is that mainly a coal?
Yeah. Yep. So there, like I said, there are different types of geologists, right? There's sedimentary geologists, there's metamorphic geologists. Under sedimentary geologists, I'm what you would call a stratigrapher, and my job is to link like beds of rock up. Like I correlate for hundreds of miles, link the beds up. But even a subset of that is coal geology, and that's what I did. That's what my training is in. How do coal seams form? What controls their quality? What controls their mineability? That was my graduate work, and that's why Colton is named Colton, Coalton. That's why Collier is his name. Collier is a person who mines, and our little guy, his middle name's Haddix, which is a coal seam in Kentucky. So I have a big love of coal. I think it's a fascinating rock. It's a really, really neat thing when you really start studying it. Anyway, I get excited about it. But
I didn't realize, so I'm familiar with coal mines. Is everyone familiar with coal mine, like digging down and finding coal?
And in the coal mine,
Yeah, it's the commonest ore in Minecraft.
Oh, that's right, Minecraft. But I didn't realize you could actually see seams of coal above ground.
Oh yeah. Yep. And we can if you ever want to do a talk on coal or mining or any of that stuff, we could always do that too. Happy to do that.
Yeah, that would be great. And where does coal come from?
Dead animals, I guess. I don't know. I kind of associate it with fossil fuels, and I know oil comes from like animals.
Coal is a fuel, so that makes sense.
Mm-hmm. So it comes, Mr. Mike, does it come from animals?
No, coal tends to come from plant material and in a variety of different swamps and settings and things like that. Some things you kind of think of a swamp. There are certainly coals that develop that way. There are things that are called bogs that you might be walking across and not even really realize it's a swamp or a potential coal forming environment, but it comes from peat. Peat is just decayed, like it says there, decayed organic matter that was preserved in special conditions.
And how long does it take from peat to the hard coal there, anthracite?
It really depends on, it is heat and pressure, but it's dominantly heat. So time is really dependent on the heat component of it. If it's a really, really hot area, you can cook it and get it to anthracite faster than you could if it was a cool, what we would call a cool area, because there's heat that comes up out of the earth, right? And so there are hot spots or areas where there's more heat being generated, and so those areas would have a shorter time frame. So there are coals that are like, 300 million years old that are still kind of, low grade bituminous, and there are coals that are 300 million years old that are anthracite. I mean, it just all depends on the heat.
The heat part.
Yep.
Any other questions about coal, guys?
And again, just offering this up, if you ever get into like geothermal and things like that, we can talk about heat and where the heat comes from and all that.
Sure, yeah, that'd be great.
Part of what I map heat in the rocks.
So someone mentioned at the very beginning, we're going to go through these examples pretty quick here. Sandstone. So this is called the Treasury in the ancient city of Petra. Has anyone ever been there?
I've heard about it, but no, I have not been there.
Don't think I've ever been to Petra before.
Yep. All right. Who knew the pyramids were once covered in limestone?
They were once white?
Yeah, they were once
Yeah.
covered in stone and most likely painted too. The paint just wore
Well, I
off.
don't know.
Then we
Yeah,
took
it
it
looks
all
like
off
the
'cause
pyramids
we
were just
were.
painted.
So any type of rock that contains over, 50% calcium carbonate, that's going to be your limestone category. You could probably do a whole slideshow on just limestone, but always thought it was pretty cool that the Egyptians used it. They also used granite in the, I think in the King's Tomb, they have granite columns inside the pyramid. Any other fun facts about pyramids?
I don't
People
have any.
built them by hand.
Yeah.
How did they even move them? I don't even think we can move them now.
Sleds, like little carrying things. They
So here's
put
some
them
more
on like ancient.
Here's some more limestone layers. So has anyone been to the Grand Canyon before?
Oh, yeah.
Yes, I have.
No.
So this is generally what you're going to see as the limestone layers in the Grand Canyon. Let's see. I'll keep going. Here's our limestone caves. Who's ever been in a cave?
Me.
Me.
This is one of the pictures that Mr. Mike was saying. He had a picture of him in a limestone cave. Is this what it looked like, Mr. Mike?
Well, the picture you had was a mine, so that was man-made.
Okay.
But I've drugged the boys to Carlsbad, and that is Carlsbad. Carlsbad is absolutely beautiful. It doesn't even look real. It's just like that.
Yeah.
And that may be Carlsbad for all I know, but Carlsbad Caverns in New Mexico are absolutely beautiful.
So how
Red Dead Redemption 2 graphics.
So how are these things formed? Like, what are we looking at? Why is it a limestone cave?
Yeah, so limestone is a really unstable rock, right? It's got calcite in it, and so any little bit of acid in the groundwater can dissolve the limestone. So if there's a crack in a limestone bed and you got groundwater moving through it, it can start to dissolve that out, and it starts to widen out, create a cave. And in that same water can then come in and percolate through the roof and start to drip down. And those are basically frozen drips of water, right? Is what you're seeing. It's just mineralization. It's the water dripping over hundreds of thousands and potentially millions of years, just dripping down. And that little drop gets to the end of the stalactite, which is the thing coming down from the ceiling. Being C, stalactite, that's ceiling C. The water gets to the end, and it deposits a little bit of minerals there, and it drips down, and sometimes it'll hit the floor and deposit some more minerals, and it'll start to build itself up. And those are called stalagmites. G is in ground. And so those things just form, and eventually they come together and form a column. And where you see the red writing there on the far right side, that's a column. So that's where the stuff is dripped from the ceiling, and dripped and, splashed up on the floor and built its way up till it connected. So dissolved limestone that was deposited by dripping water effectively.
So is the water in the cave generally rich in this stuff, I'm guessing?
Is it rich in like calcium and things? Probably. Yeah. Yep. And sometimes in the rock record, we will find paleo caves. So caves that were 200 million years old, right? You can't get in them anymore, obviously. They're these things that are kind of collapsed in and all that. But when we drill, sometimes we can tell that that's what we're hitting.
All right, so are you familiar with, okay, how do you pronounce this word, Mr. Mike? Is it karst?
Yep, karst.
Okay. So these are very similar to what you just said, but under the ocean, correct?
Yep.
Okay. So this is the Great Blue Hole. Very famous. Have you guys seen this before?
Yeah, because in all of those
Yeah.
crappy Megalodon videos, they're like the Mariana Trench, and then they show that. It's not even the same thing.
Yep, karsts are just sinkholes, and they're basically collapsed caves. That's what they are. And in places like Kentucky, Florida, where there's a lot of limestone and you get a lot of dissolution, a lot of cave formation, the collapsing of those, you'll get karst topography, which is very distinct. You can usually see it very, very clearly from the sky and different types of maps.
All right, and this is the Terracotta Army. Who is familiar with that in history class?
Terracotta from Minecraft.
Me.
Oh, is that
Me.
Minecraft again?
Terracotta is in Minecraft. Yes.
Yes, it is.
Yeah,
They don't have
I can't
terracotta.
believe
in
nature
Bible.
stole from Minecraft. Minecraft needs to sue nature.
So these are all made out of clay. And what else comes from sedimentary rocks? Well, here's our fossils.
Fossils.
Right? Fossils in sedimentary rocks. Yeah. And we can do a whole unit study just on paleontology and studying fossils.
Yep.
All right. So our last one is metamorphic rock. And that just means meta change and morph shape. So this is a rock that's going to change some shape. And it can form from existing rocks as long as it's exposed to heat and pressure, right? So here's an example. This is a mountain range that was limestone and turned into
Marble.
The Antarctic marble. Marble.
Yeah. So who has marble in their house?
Pretty sure we do.
Yeah.
I don't even know. I think we have
Marble table.
like glazed marble. on
But
our
not the
tables
marble.
and-
So if you have,
Is marble used in marbles?
I wonder if that's where the word marble came from the, or well, you're
Little
talking about like
balls.
playing marbles. Yeah. They might have been made out of marble originally, maybe.
Yeah, that's what I'm asking. Are like marbles made out of marble?
Like I made out of plastic now.
Yeah, they wouldn't be now, yeah.
So,
Like if one landed on you, it would be.
do you mind
Does
if I?
anybody know what, does
Um,
anybody know what this is?
That's the Taj
Taj
Mahal.
Mahal.
That's the Lego set.
In
one.
India.
Taj Mahal.
All right, so this is made out of marble. So this is what type of rock again?
Marble.
Marble.
Marble slab.
Sorry, what category of rock?
Metamorphical rock.
There you go, metamorphic rock.
Ask you can ask a question.
All right, so why can we carve in marble?
It's soft.
So,
Soft and weak.
it maybe it. I don't know.
Soft,
Mr.
weak, and
Mike.
easy to access, I guess.
Mr. Mike, is that correct?
Say it again. Sorry.
Why can we carve in marble?
Because it's softer.
Yeah.
So marble being limestone, former limestone, it is just a softer material versus a sandstone, which gets converted to a quartzite through heat and pressure and is much harder.
Oh my God, nature stole from Minecraft again. They stole quartz.
Emma,
God.
I have an answer to your question.
I feel like it's the other way around.
Are we muted?
Yeah.
No.
Nature should be suing Minecraft.
When's
No,
Kahoot?
Minecraft should be suing
All right.
nature.
So we ran through the last bit pretty good. So hopefully you guys will do pretty well in the Kahoot today. We covered most of it. But I want everybody to thank Mr. Mike for being here and helping us out today.
Thank you.
Mr. Mike.
You're welcome. I always like talking about geology. So
Can I ask
Well,
a quick
Thank
question?
you.
Yeah,
Thank
go for it. Ask your questions.
Thank you, Mr. Mike.
Why are the earthquakes going on in Turkey?
So that has to do with plate tectonics again. When the plates move past each other, it's not a smooth transition between two plates, and there's a lot of friction because the materials are gritty, right? Think about it that way. And so what happens is the movement continues and stress builds up in the rock until it just can't hold it any longer, and then it shifts along a fault line. That's the definition of a fault, is where there's been movement, and that release of energy is just tremendous. And that's what happened over in Turkey, unfortunately.
Hi, Dad.
Hi, buddy.
Do you have any questions for your dad? Anybody else have any questions? That's right. They're used to it at the house, huh?
Yeah.
Anybody else have questions?
I have an answer for Emma.
Go you Kahoot.
Me?
Yes. So marbles have been used in games for industrial tasks since the ancient Romans and Egyptians. They began making them out of stone, clay, and marble. Modern day marbles are made of glass.
There you go. Thank you.
That's pretty cool. Thank you.
You're welcome.
Gotta love the internet. All right. Well, we'll play our quiz game next, guys. Is everyone ready? And Mr. Mike, you're more than welcome to play with us, or you can leave.
I'll probably head off. I've got some work I got to get done, but it's been a lot of fun. I appreciate you having me.
I'll start my Kahoot.
Hi, Dad.
So how does the sun rise in Minecraft if the world is infinite?
You're hurting
All
my
right.
brain.
I'll let you answer that, Tara.
Okay.
See you later.
All right. Bye. Thanks.
Yeah.
Straight up hurting my brain.
All right. So we'll do
Kahoot, yay.
Yeah, let me share my
I
screen.
don't know if I'm
Okay.
ready for Kahoot. Gavin and Graydon are on the call today, and they're like my nemesises.
Nemesis.
Well, did you take
Did you take your
notes?
regular
Sounds
notes?
like people are wanting to play Minecraft.
Yes, I took some notes.
Great.
All right.
I
So
did
if
too.
everybody has Kahoot, you just go to Kahoot
Yeah.
.it and you just put in the game pen.
Where do you play?
Okay, 1 sec.
Hey, you made this one.
Okay.
Got quiet.
Who is Safgigo Bob?
You want this screen a little
A
bigger?
lot of players today.
Okay.
Or Fred?
Okay. I'm gonna try this again. Hold on. I'm not in yet. 1 second.
Okay, that's fine. We have a bunch of people not in yet.
So I'm assuming because people were talking about Minecraft, they want to play Minecraft.
I'm George Washing Machine.
Oh, you know, Mr. DeMayo.
Yo,
or
George
DeMayo.
washing machine.
Hey, who's Ohio?
You really have to guess that.
Levi. It's Levi.
No,
Oh,
it's
Oh, I
not.
thought it was you, Ashwin.
No,
Yeah.
Ashwin's always monkey.
Wait, is Ashwin and Levi, are they brothers?
No.
Bro,
Oh
what?
my
Levi's
God, no.
Levi's your
Whoa.
brother.
I don't know what to say about that, bro.
Levi's
Guys
your
are about to
brother.
get
What?
Ashwin's just Levi's friend, and they just have like the same strange thoughts.
Emma, you in yet?
My guy's really trying to get canceled.
Oh,
What do you
my
mean
God.
by that? What do you mean we're brothers? What led you to that observation that you have there, sir?
I don't know, it was just a
Yeah,
guess.
I'm almost in.
I
Yo,
mean,
that-
It's connecting.
you guys do like always talk about the same thing, so maybe.
No.
Secretly brothers. The story of a
Secret
lifetime.
brothers. I have a second brother.
Oh, wow.
What if we were sisters?
Haha, I'm moving to Canada with you. And taking everyone with me.
Everyone?
Everyone.
You can't have pet mice in Canada, though.
I don't have a pet
Who said-
mice.
Who said she had a pet
Oh, you
mouse?
can never get one then. I don't even think you can have hamster. There.
Oh, Emma, didn't you tell me you had
Hamster.
a pet rat?
Hamster.
Luckily,
You can't even
don't
have a pet
any pets.
hamster.
I don't even think you can have a pet hamster.
All right, Emma, you in yet?
It's being finicky.
You want
Um,
to
Typical
anime
L
guy.
can't join.
try to go to the other internet? And it might work.
Who's the anime guy?
You guys have 2 internets?
Yes, because in Canada, they do not get anything we need in the United States. Like if we want to watch something. So you have to get a second thing called a VPN.
Oh, so you
NordVPN?
This
Oh,
video is
okay.
sponsored by NordVPN.
So I think technically we're in Dallas is what it is what we got.
Okay.
Yeah,
It must have some bad connection.
they're very, very restrictive here on what
Hey,
you can-
imagine
Wow.
if Jesus.
Dude, I always
before
thought Canada was
got
open.
crucified.
Yeah.
No, you can't see a lot of, I don't think you realize it until you've lived somewhere else, but you can't see a lot of things on
Hey, same thing in the
Do,
US.
do they like restrict news and stuff like that?
what I could tell, yeah, but I don't think
Oh,
they
Oh,
announce that.
that's a little strange. That's
I don't
mad
think they
strange.
announce.
yo, I thought
But I
Canadians
can-
were
I can
nice.
get-
So when are we gonna
With
start?
with a VPN, I can get all the news now. Yeah.
Yeah.
All right, let's see. All right, Emma, are you on?
No,
Okay.
it's
Wow.
not letting me connect.
All right.
Look how happy and chirpy I look.
Did you switch internets?
Oh my God, Tara teleported. He's a witch.
Traveled the multiverse.
Yo, I'm
Your
not
call
winning.
has been forwarded to an automated voice messaging system.
Why is
81841.
I just declined
happening?
option. I just declined option.
Leave my answer, please, bro. I gotta tell you something.
Bro, why is that the
That,
face
that
cam?
proves that
What do you
Levi's
mean?
your brother, or at least your friend.
Yeah.
Oh,
They're friends.
No.
No, they're not
Oh.
friends. They're not friends.
And why do you have
Oh.
fun?
hey, why do you want hanging up
Oh,
on me, bro? I gotta tell you
no.
something. Bro,
Well, tell
phase
them
up,
over
yes or no?
Okay, so we're all
How do
ready to
you
go.
say that name?
All right, is everyone on now? Yes, we're ready to go.
Yes.
How do you even say that name?
No.
Oh, my name?
Fair Fred George Washington.
Did someone ask how to say my name? Say my
Your
name.
Kahoot name.
What is not a layer of Earth? Oh, this one. Oh, I know that.
In the Krypton core.
Yo, the
My
grandma.
Is that Spider-Man?
I think, dude, it's
The
Spider-Man.
superhero gives you a
That's the
hint.
Incredible Iron Man, right?
Spider-Man.
That gives you a hint.
My
Who
name
answered
is
upper
actually-
mids? I'm first. Yes.
Which type of ancient rocks comes out of the ground?
My name is actually
Intrusive
the
thoughts.
Oh, what is it?
Yeah, the answer is intrusive
I
thoughts.
think I literally clicked the wrong one. Oh wait, no, I did. I
Oh
clicked the
God, no, I
first one.
misclicked. What do you mean? Ha!
Just laughing. Like, which are not a catastrophic rock type?
It's metamorphic, guys.
It's
Metamorphic.
stondominium. Bro, what is stondominium?
Stondominium.
Stondominium.
Oh, good people the answer.
Oh, that's some different
The
planet.
podium.
How am I in fourth place? Who keeps taking my spot?
Well, you have to be. It's all about getting the right answer and how
This
quick you are.
comes from the Latin word fire, smelly, hungry rock. It's pretty obvious.
It
I'm just
has
gonna
to be
guess,
smelly.
bro. It's smelly.
Yeah.
Why is Graydon always the one sent first every single time?
Why is bro
Because
eating a
they're
hamburger?
smart.
Why is bro eating a
Yo,
hamburger?
what?
Podium. I'm still.
Excuse me, how is that wrong?
I'm first place.
No. Magma can be as hot as
the sun.
August in Texas. Makes sense.
I'm gonna go with 1400 Celsius.
Yeah, August in Texas sounds like a very good answer, actually.
August in Texas.
Who answered the sun?
Me.
Oh, I'm worried about.
23 points behind Gavin.
Cools and stays underground. It's not living. It's not cool. It's
Yo, it's not living up
Not
to its full
living up to its
potential.
full potential.
The ground
It's not
lava.
living up, bro. It's called ground lava.
Ground lava.
It's called ground lava.
Typical ground lava issue.
I know.
Yeah.
Honestly.
Rocks that contain a lot of magnesium and iron.
Yo, it's the Thor's
hammer.
I got to be Thor's hammer. If you don't answer that, you're
Bro, I got it wrong.
SpongeBob SquarePants.
One.
I
Why did you
actually
say
clicked.
pants?
No. Whoa, what do you mean?
A lot of
How did I get that
Yo,
wrong?
Felsic has more silicon.
That's
Yeah,
great.
more silicon and oxygen, but maybe because
I'm not up
iron and
there anymore.
magnesium.
No.
Guys, do you know what my username is?
Red birds.
I love how someone just gave us the answer accidentally, not knowing them.
My username on Kahoot. It is my name.
Yes,
is
I'm
F-
slowly climbing up. L's in the chat.
Bro, I missed one question.
My
I'm
name
14.
is actually
The most common volcanic rock on Earth's surface.
It's us all.
what?
Hey, bro, what is that?
Yo, it's
What is that image?
Blah, 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 what's it called? Basalt.
So what is that
Bro,
image?
I've missed one. I missed
Bo's
two
legit gonna
questions.
1v1.
I missed two questions. I'm in 14th
I'm
place.
165 points behind Monkey.
Average.
Yeah, get wrecked, kid.
Electric lava can.
I am monkey.
Full like
Call
melted.
your mother.
Your mother.
Yo, I can call your mother.
Right, bro. Personally, I wouldn't be taking that disrespect off of it. That amount of disrespect from lava is intolerable.
Uh-oh.
So you don't really smell like a monkey.
Ah! Ah!
Insert explode into space. I want to know.
Someone's just a troll.
Who did
Someone's
it?
just trolling.
Calcium magma can tap
No.
trap
Winning a staring contest.
Staring contest.
Wait.
Yellow
Mill
are
your
both
wait.
true.
Mill your
Listen
face
quietly.
should-
Listen quietly.
No.
Yo, yellow. It should be yellow because it can melt your face.
I mean, both
true.
red and yellow is true.
Goose
Yo,
fled.
you got it wrong. Yo, I'm 8 points behind Monkey.
Get wrecked, kid.
I have no idea. Boom.
Yo, it's made of sentimental thoughts.
Lazy rock.
It's made of sentimental thoughts, bro.
Does anyone want to know the history behind my name?
No,
Oh.
you monkey. Who's Ohio?
Me.
Who is Ohio?
You
Me.
really had to guess again. Hey, rock.
Any
Any
rock?
rock or mineral that can be carried that can be
Water doesn't have arms to carry anything.
any mineral particle that can be carried by water.
Water doesn't have any arms to carry anything. That is true.
Yo,
is
no,
true.
it's called weak. Maybe.
Yeah, they're just weak. They're just
They're just
skeleton.
weak. They're just plain weak.
No one
Yo,
can
I'm
top me. I'm better.
Get
stronger,
something
faster,
wrong,
smarter.
Ohio. Ohio, please.
Plastic rock needs
It needs duct
Glue,
tape, bro.
glue,
No duct
glue,
duct
glue.
tape solves everything.
Glue.
Duct tape solves everything.
We need
Duct
that. We
tape
need
solves
What
that.
if you're
everything.
hungry? You can't just eat it.
Bro, are you serious right now?
What if you're hungry and don't want to die?
You get rid of the potassium
Of the minerals we get.
Angry has broken home.
A broken home.
Chemicals.
Yo, it's a broken home.
Angry class. The picture's ridiculous. Bro, what is bro yelling
Yo, it's
at?
just a broken home.
He broke up with his Roblox.
Ah,
Yo, it's a
Ohio, get out!
Why do you scream so much?
I don't know.
The Addams family.
Yo, Addams family.
The Kardashians.
I just picked a random one.
The Addams family.
Yo,
I think I answered wrong.
Addams family movie. Oh, yay.
Adams. No, no,
Zuko
no,
Midoriya.
no.
I can play the Addams Family on the piano.
Ashwin, get something
Oh
wrong.
my god.
Ashwin, get something wrong, alright?
Timmy fell in the well.
Timmy legit fell into the well.
Timmy
Yo,
fell in the well.
I would hate to fall through that hole.
Yeah.
For real, for real.
Who is?
No,
Who's Izuku Midoriya?
Bro, I am 100 points behind Monkey.
Yeah, I get wrecked, kid.
Oh yeah. Levi.
Can't break.
It's dark. It's dark. It's dark. It's dark.
It's
Pressure
dark.
and heat.
Oh,
buddy.
Levi.
Bro, you might find them aliens.
Levi.
Yes, it's Emma. Yes, Emma.
Pressure and heat.
You know how to solve the problem
I
of,
just realized my
dying
mic was
when you fall
muted
in
that
a hole?
entire time.
How?
It's find
You
aliens.
just
Formed when magma
just,
cools.
you equip your paraglider.
What?
Oh.
Guys, that's cold lava rock. All right.
Cold lava.
I think I.
How do you-
I think I did. I got it right.
How do you
Oh,
survive
goofy
falling down
odd
a
question.
10,000-foot hole?
A machine used to study inside the earth using waves.
Yo, it's one of
With
the-
a waveometer.
It's
That
a
extra.
waveometer.
Bro, thinking Mr. Beast.
Mr. Beast. Mr. Beast.
Nah, bro, thinking Mr. Beast.
L, Ashwin, L.
Mr. Beast, Mr. Beast.
Layer right under the layer right under the mantle.
A layer under the
It's that, bro.
mantle.
It's that hot layer, bro. It's that hot layer.
Yeah.
It's that hot layer.
Hot layer.
Nah, bro, thinking Mr. Beast.
Mr. Beast. Mr. Beast, Mr. Beast.
No.
I'm in Disney place.
Bro, who's Mustard God?
I am mustard god. I literally said I'm a washing machine.
We drill for oil and find fossils.
Bro, we drill in the inner core. We drill in the inner core.
Yeah.
It was either sedimentary. Sedimentary.
No, bro. We drill in the inner core to find these fossils.
It was sigma. It was sigmatary.
Who's third place?
Dang, Emma fell
I'm in
off.
third place. I'm coming for you, Lucky Banjo.
Flows into
That's
water.
me.
The coin is not more crystals. Obsidian.
Maffic.
There's Jello.
Yeah, it has to be Jello.
No,
Bro,
it's
it's
obsidian.
Jello. It
I
has to
think
be.
I
I
got
don't know,
it
it's
to be
Jello, guys. If you
Bro,
didn't
it
pick
has
Jello,
to
then
be
you got it.
Jello.
Oh, I think I got this wrong.
It's Jello. It's Jello.
Oh my god, I got it right.
Yes, it's
Better be Jello.
Who's bye?
Oh, Emma.
Yes, sir.
Basalt
Don't
is.
do
I'm
basalt.
probably gonna lose it as soon as
No,
possible.
it is
though.
Uzi.
I think it's May.
Oh my god, guys. Can you believe that? I think I got this wrong.
Oh,
I
it's
think I got it wrong too.
Mafic
got it.
magma?
Uh-oh, I'm gonna go all the way to the bottom.
If you
I'm
don't,
gonna
if
go
you
Please
on
don't be
if you
wrong.
choose-
Please don't be wrong.
If you choose felsic magma, you.
Let's go! Ohio!
I chose Felsic.
Yo, who chose good to put it on a sandwich?
I'm in
Who
third
chose
place.
good to put it in a sandwich?
Melted granite is.
Make a mistake.
Oh, mistake.
It's a bro. It's a
You
discounted countertop.
discounted countertop.
Yeah, it's a discounted countertop. It has to be.
No,
That's why
it's a
discounted
mistake, guys.
Oh.
countertops.
It was an honest
Oh,
mistake.
magma.
Please be right. Yes.
I'm in granite.
Yes. Yes.
Ohio, you're built like a big bean.
Bro, I'm in 8th place right now. I'm in 9th place right now.
I'm in third.
Of rock formed when magma cools.
Didn't this already
Mm,
like?
Ignius.
yeah, we already did this.
Ignius. I won't
No,
get it
it's
wrong this time.
ice. Bro, it's ice.
Ice.
What do you mean? It's ice.
It has
No,
to be.
it's not. Stop lying.
Bro, I'm in 8th place.
Bro, spitting false
Bye,
information.
bye, bye. What?
Weathering and type of rock. I don't know.
Bro, it's that old rock. It's the old
Old.
rock.
Old.
An old rock. bro.
Rocks.
Just rock.
It's an old rock.
No.
Oh, bro, I'm
You
in
got it
7th
right,
place.
bro.
Who was
Who's
Lucky
CR?
Banjo?
Who's CRW?
I'm still at the top. I'm still at the top.
Temperature and pressure can change rocks into. Tell me rocks.
It's
and-
Highly anxious. No. Bro, it's the
Highly
powerful
anxious
entities.
rock.
It's the powerful entities.
The powerful entities.
Bro, it's these powerful entities.
Who chose highly anxious rocks?
You did.
I'm pretty sure Ashwin said he was gonna
There's
troll.
one for you, interesting. You're
No, I'm not trolling. I'm not trolling.
It's released from prison.
Yeah.
It's released from prison.
Bro, it's released from prison.
I mean, this is actually partially true. The argon is trapped into the magma and then it released, so it kind of is.
But why
like
are you
being
giving people the
released from
answers?
Released from prison.
Who chose released from prison?
Somebody's trolling, and I really want to know who it is.
You.
Levi.
I'm not
It's either-
trolling.
Bro, no. I'm in
Either
7th
Levi
place.
or A.
Oh, can record the Earth's change in.
Bro, I'm not
Iron.
doing. Bro, I'm not doing it. I'm in 6th place. I
Guys,
will
it's
not
attitude.
be defied.
It's attitude.
Bro,
Attitude.
no. It's attitude. It can't not be attitude. It has to be attitude, bro.
I'm
Somebody
in
chose
13th
it.
place.
Because of you,
Who's
somebody chose
trolling?
Yo,
it.
someone is still trolling.
All right, who's in last place? It has to be that person.
I'm
Yeah,
in
it has to be.
13.
Dinosaurs are.
Dinosaurs are
If I
real
accidentally
smart, bro.
selected the Earth
Yo,
as
dinosaurs
Dinosaurs
Are a conspiracy theory.
Earth is shrinking.
conspiracy theory. Hey guys, welcome to another episode of Earth Theory.
Yo,
Who
the
chose
two
the
people be
Earth is
trolling now.
shrinking?
I'm your host, Matt Pat.
You're not Matt Pat.
Geology is cool because I get to
I
learn
can't.
how the Earth works.
You're
I can be
cold.
covered in dirt and my mom can't get
Can't get
mad. That is
mad.
a great W. What the?
Oh.
Oh my
Decline.
No,
I
Seth,
took a
Seth,
screenshot of that. I took a
Old
screenshot.
number
I
back.
hope yeah,
Calling.
screenshot that. We call that number.
I'm gonna call that number.
But I'm in last place.
Good, it's spam.
I
So I had to turn it off.
And I keep missing them on purpose.
Wait,
Spam
I
calls.
was 475.
I think
Did it
Please
ruin
let
the
me
game?
be.
Oh,
I don't know what
Please
happened.
let me
Levi,
be.
what
Cap-
happened? What happened?
No!
Hold on.
Say it again?
Skip.
Ah.
Please, please, please,
Did it
please.
ruin the
I
game?
can't
no,
hear you.
please. No, please, no, please, no, please.
Oh.
reconnect.
Is that happening to everybody? It's connection issues?
Yeah,
Say
it
that
is.
again?
What?
What?
Everybody know what place they're in right now?
I was in.
second.
Bro,
I'm
I'm
in
in
second.
7th.
I'm in
I'm in
10th.
7th.
I'm in first.
All right, Emma's in first. I'm in third. Oh, great, it's working now.
There
Oh,
it is.
oh, oh,
Okay, good.
See, let's see this.
Yay, I'm in third place.
All right, guys, we did it, and it
Right.
didn't join us.
It's not loading for me. It's just.
Bro,
I got second place.
Bro, this thing says I have 0 points.
Oh wait. because
says that.
Okay, there we go.
That proves you guys are trolling.
All right, guys. You definitely don't need it. The answer was I can get covered in dirt and my mom can't get mad, right?
Bye.
Oh, bye.
Okay, good job, guys. Did everybody get it?
Bye, guys. I
Bye,
got second place.
I got 13.
Good job.
Bye.
Here, I'm
I
gonna
thought
stop.
Gavin was gonna beat me today.
Bye. Zoom.